Good morning, guys. I am Vasi Priya from Vasireddy Venkatadri Institute of Technology. Today, in this lecture, I am going to discuss about shift instruction from computer organization. Let's see what are the topics we are going to discuss in this lecture. That is introduction to shift, type of shift instruction, logical shift instruction with example, and arithmetic shift instruction with example. First, let's discuss our first topic, introduction to shift. In order to perform any operation on mission, uh, then the mission language is the plays a key role. That means the mission performs every work only using the mission language. Here the mission language consists of binary values. They may be zeros or ones. Hence a mission or system works on the mission language which consists of binary numbers, and these binary numbers are zeros or ones. And in order to manipulate the bits of the binary values stored in the registers, then we need to perform shift or rotate instructions by the processor. Hence the shift and rotate instructions are used in the computer processes to manipulate the bits of the binary value in a register. Hence, what is this shift instruction? What is this rotate instruction? What is the difference between a shift and rotate instruction? In rotate instruction, the bits that will fall off will be wrapped back to the other end, whereas in shift instruction, the bits that will fall off are discarded. In rotate instruction, if the left hand side bit is fallen off, then the same bit is wrapped back to the to the left side. When the right side bit is fallen off, same bit will be wrapped back to the right end. This is how a rotate instruction will work out. Whereas in shift instruction, once the bit will fall off, it will be ignored or discarded. It will not be wrapped back to the other end. That is the major difference between the shift and the rotate instruction. Now let's move on to what is the shift instruction. In the shift instruction are used to shift the bits of the binary value to the left or to the right, filling the empty bit positions either with zeros or ones. Suppose if the bits are moved towards the left, then a empty bit position will be occurred on the right end, and it is filled with either zeros or ones in the shift instruction. Suppose if the bits are moved towards right, then empty bit position will be occurred on the left, and it will be place it either with 0 or 1. This is how a shift instruction works. They are classified into two types, that is logical and arithmetic. Logical is sub-categorized into left and right, whereas arithmetic is only right. Now let's see in detail about the logical left and right. Here, a logical shift instruction. What is a logical shift instruction first? It is similar to the definition of shift instruction. Here, once the bits are shifted to either right or left, then the empty bit position is filled with zeros. That means if we perform the shift towards left, then the empty bit position on the right is filled with 0. If we perform the shift operation on the logical shift operation towards right, then the empty bit position on the left is filled with 0. That means here the logical shift right format for the logical shift right is L shift R hash value comma destination. Here hash value will define how many times the logical shift right should be performed on the destination. In logical shift right, all the bits of the binary value are shifted towards right, and the empty bit position on the left is filled with 0. In logical shift left, the format for logical shift left is L shift L hash value comma destination. Here value specifies how many times the logical shift left should be performed on the destination. So in logical shift left, all the value bits of the binary value are moved towards left, and the empty bit position on the right end is filled with 0. Let's see with an example, logical shift right and logical shift left. First, logical shift right example. Here, logical shift right hash 1 comma r naught mean once the logical shift right should be performed on r naught. Initially, the binary value stored in r naught is 10111010. Here, the MSB bit is moved a bit towards right, and then 0 is moved and then 1 is moved to right, 1 is moved to right, 0 is moved to right, and 1 is moved to right. And finally, the LSB bit, that is the least significant bit, 0 is moved to the carry forward. And this carry forward is ignored or discarded. Initially, carry forward is filled with 0. As we moved all these bits 0 1 1 0 towards right, an empty bit position will be occurred towards left. Hence, this is filled with the 0. Hence, the final value after performing the logical shift right, the binary value stored in R0 is 0 1 0 1 1 0 1. So 1 is moved a bit towards right. Next 0 is moved, 1 is moved, 1 is moved, 0 is moved, 1 is moved. But the last left significant bit is moved towards carry forward. And 0 is inserted at the right end, at the left end. This is how a logical right shift operation will be performed on the binary values. Suppose, let's see how a logical left shift operates. Here, let's consider only once the logical shift left shift should be performed on R naught. So L shift L hash 1 comma R naught. Initially in R naught, the value stored is 10111010. Hence, the carry forward initially we assigned it to 0. Hence, 1 is moved to the carry forward, that is MSB bit is moved to carry forward. Whereas in logical right shift, the LSB bit is moved to the carry forward. Whereas in logical left shift, the MSB bit is moved to the carry forward. And then 0 is moved, and then 1 is moved, and then 1 is moved, and then 0 is moved, and then 1 is moved towards left, and then 0 is moved towards left. Here we get a vacant position as this bit is moved towards left. Hence, this vacant or empty bit position is filled with 0. And this carry forward is ignored. Hence, the finally the binary value stored in R0 is 0 1 1 0 1 0 0. Has as the R0 is the destination itself, after performing the logical shift left, the binary value 0 1 1 0 1 0 0 will be stored in R0 itself. This is about the logical shift left with an example. Now let's see how a arithmetic shift will be performed. In arithmetic shift is a shift operation that shifts the bits of a binary value to the right and filling in the empty bit position with the sign bit. Means all the bits are moved towards left, and there will be an empty bit right on the left side, and that is filled with the previous MSB bit. Previous MSB bit is filled in the left empty bit position. Hence, the left shift operation, the shifts all are towards right and filling the empty bit position with the sign bit. Here, the arithmetic shift instruction is only towards right, and the format for right arithmetic shift is a shift r hash value comma destination. Here, MSB bit is preserved. As I said before, the MSB bit is filled in the empty bit position on the left end. Hence, MSB bit can be preserved. That is, sign bit is preserved in arithmetic shift instruction. I think you will get a better understanding if you see the example. Arithmetic shift example. Here, arithmetic shift R hash 1 comma R naught. Initially, the R naught binary value stored is 10111010. As I showed in the before example, the same R naught value I have taken. Here, I'm performing arithmetic shift right only once on R naught, specified by the value, that is value is 1. Hence, only once we need to perform the arithmetic shift right on R naught. Here, the MSB bit 1 is moved towards right, 0 is moved towards right, 1 is moved towards right, 1 is moved towards right, 0 is moved towards right, 1 is moved towards right, and finally the LSB bit is moved towards the carry forward. Hence, this carry forward is ignored. And here the MSB bit is 1, and this MSB bit is preserved. That means here in MSB bit is filled with here the MSB bit is filled with the previous sign bit. Hence, we can say that the sign bit can be preserved. Same one value will be copied, and these are shifted towards right, and final LSB bit is shifted to the carry forward. Hence, after perform arithmetic shift right, the R0 binary value in R0 is 11011101. Hence, Once we had performed the arithmetic shift right on the initial value stored in R0, and the final result is stored again in R0 itself, as it acts as destination. This is how we can perform arithmetic shift with an example. Now, I think you have got the clarity on how the logical shift instructions will be operated and arithmetic shift instruction will be operated. The major difference in logical shift is the empty bit positions are filled with zeros, whereas in arithmetic shift is the MSB bit is filled in the empty bit position. Hence, this is all about the logical shift and arithmetic shift. Uh, this is thank you. And